All right, welcome to this explainer on Lore, a brand new open source version control system straight from Epic Games. Look, if you've ever found yourself just sitting there staring at a progress bar that hasn't moved a single inch in 20 minutes because you're trying to pull a repo packed with massive assets, you are definitely going to want to pay attention to this. Today, we're diving into a system that was built from the ground up to solve the massive headache-inducing scalability issues developers face with giant files. We're going to unpack exactly how it all works and why it might literally change how we handle huge projects going forward. So, let's just quickly breeze through today's roadmap. We're going to start with the core problem of scaling, then we'll unpack Lore's unique architecture, check out its open source ecosystem, and finally look at where all of this technology is heading. Okay, jumping right into section 1, the scalability challenge, and dealing with scaling code alongside huge binaries. If you work in game development or virtual production, you already know the struggle. Mixing your traditional, lightweight code with massive binary files, your high-res textures, your 3D models, audio banks, it usually just completely breaks conventional workflows. So the absolute most crucial question we have to ask first is how can we possibly version control gigabytes or even terabytes of binary assets without grinding our machines to a halt? Traditional version control systems, well, they were fundamentally built for text, right? They're fantastic at tracking changes in lines of code. But the second you throw a 10 gigabyte compiled binary or a massive raw video file at them, they just choke. The repos become incredibly bloated, cloning takes hours, and branching becomes a total nightmare because it duplicates way too much data. The status quo here is just painful. Traditional version control forces these massive upfront downloads, meaning you have to pull the entire history and every single asset just to start working. And that creates those bloated repositories and agonizingly slow branches we all hate. Lore, on the other hand, takes a totally different approach. It hydrates data on demand. It gives you free, lightweight branching, and it heavily relies on shared, reusable data. You literally only download what you actually need, exactly when you need it. Let's move on to section 2. Enter Lore, the solution built by Epic Games. To really grasp how robust this thing is, you have to look at its origins. Epic Games didn't just build this as some kind of theoretical in-house experiment. They actually designed Lore as the underlying engine for the Unreal editor for Fortnite, UEFN. And if you know anything about Fortnite, you know the scale there is just staggering. We're talking millions of assets, continuous live updates, and massive collaborative environments. Because it powers UEFN, Lore has already proven in the real world that it can handle unprecedented production-level scale. But the benefits, they go way beyond just managing storage size. Lore gives you incredibly easy setup, paired with on-demand scalability. It gives you free and fast branching, which means you can finally experiment and iterate without stressing about duplicating massive files. Plus, it provides a history you can completely trust because it's tamper-evident by design. It's got an intuitive command line interface, giving you full access right out of the box, and, absolutely crucial for us developers, it offers a full Surface API so you can seamlessly hook it into the pipelines you're already using. All right, section 3, architecture under the hood and the mechanics of scale. Let's get into the technical deep dive. To really understand how they achieved this scale, we have to talk about the secret sauce here, content-addressed storage. This concept anchors Lore's entire approach to wrangling huge files without all the duplication. Instead of referencing a file by where it lives or what it's named, Lore references data by its content hash within a Merkle tree. What this means in plain English is, say you have the exact same texture file used across 3 different projects or branches. Lore is only going to store it once. It knows it's the exact same file because the cryptographic hash is identical. This allows for lightning-fast comparisons, immediate integrity checks, and a massive amount of data reuse across your entire history. And because it relies on these Merkle trees, your repository actually forms an immutable revision chain. This is a cryptographic structure where a revision's unique signature is mathematically derived from its state, its parent revision hashes, and the hashes of the data it holds. Meaning your repository's history is cryptographically secure and tamper-evident. If even a single byte of an asset from 3 years ago somehow changes, the hash changes, and the system knows about it immediately. You get absolute confidence in your source of truth. So how it actually handles giant binaries without completely choking your network is incredibly clever. It uses a chunked storage workflow. Instead of saving a massive binary as one giant heavy block, Lore splits it up into smaller, reusable chunks, indexes them by hash, and, here is the real magic, when you update that file later on, Lore only transfers the specific chunks that were modified. If you just tweak a tiny corner of a 5 GB texture, you aren't re-uploading 5 GB. You literally only transfer the few megabytes of chunks that actually changed. I mean, that is an absolute game changer for iteration speed. And because of this highly efficient chunked architecture, Loracolic unlocks what they call sparse workspaces. Your local workspace can stay completely lightweight. You only fetch and download specific file data when your system actually needs it. Imagine joining a massive, multi-terabyte studio project and being able to start working on your specific code or your scene in just minutes. You completely bypass those massive upfront downloads that just notoriously kill productivity. Moving right along to Section 4, the Lore ecosystem and how it's built for multiple languages. So if we want to integrate Lore into our own pipelines right now, obviously performance and safety are paramount. That's exactly why the core library and the centralized server are overwhelmingly written in Rust, making up over 81% of the codebase. Rust gives them that low-level control and memory safety that a high-performance system like this absolutely demands. And that's supported by a solid chunk of Python, about 14%, and a little under 4% C. But hey, you aren't limited to just Rust. Epic Games really designed this to be extensible, and the ecosystem already features dedicated SDK bindings for JavaScript, Python, C#, and Go. This means whether you're spinning up web dashboards, writing backend automation scripts, or integrating directly into a game engine using C#, there's an SDK ready and waiting for you to hook right into the Lore API.
Which brings us to our final section, Section 5, an open source future, looking at the community and licensing.
Wrapping things up, the community momentum behind this project is already just immense. Even though it's in its early stages, the repo is already boasting over 1,400 stars and 57 forks on GitHub. Developers are watching this incredibly closely, basically because the pain point it solves is so universal across the entire industry. And honestly, what's truly exciting is Epic Games' approach here. They haven't gatekept this behind some proprietary, wildly expensive enterprise wall. They've released this pre-1.0 project fully open source under the highly permissive MIT license. As they boldly state directly in their documentation, they are actively inviting the community to come collaborate and help build the version control system of the future, completely in the open. Which really leaves us with a final thought for today. The dividing line between standard lines of code and massive digital assets is rapidly disappearing. As terabyte-sized projects become the new everyday standard, is your current version control system actually going to survive the transition, or is it time to start building with Lore? Thank you so much for joining me on this explainer, and keep building.